Okay, so this is our first lesson on naming compounds, and here we're going to talk about binary ionic compounds. That's just a fancy word that means two different elements. Okay, two elements together is a binary ionic compound. Depending on the type of element, two elements, one that's a metal, one that's a non-metal, that's a binary ionic compound. Okay, and there's a system that we use to name binary ionic compounds. You're going to learn the system. That's the idea. Okay. Chemical bonds are links between elements which result from a force of attraction between two ions of opposing charges. Okay, so ionic compounds are a metal and a non-metal together. That makes an ionic compound. Okay, and another way to think about ionic compounds is ionic compounds have a gain and a loss. Well, yeah, one of them gains and the other one loses electrons. Okay, or you can think about it as like a transfer of electrons. That's also just fine. And this happens because metals form, since metals form positive ions, that is, they lose electrons in order to become stable, and non-metals form negative ions. Okay, and positive ions and negative ions actually have specific names. There's a term for a positive ion, and it's a cation. Okay, and a negative ion is called an anion. So I remember, like, you can use a bunch of different ways to remind yourself of how these things are named, but for me, I think of, okay, maybe you like cats. I'm more a dog person myself, but maybe you like cats, so positive cation. Okay, maybe you don't like onions so much, or they're stinky, or in my case, you're allergic to them, so anions. Okay, sounds like onion a little bit. So onion, negative, anion, positive, cation. Okay. Before we talk any more about naming these ionic compounds, we're just going to talk about their properties for a little bit, just so that you know, like, molecular and ionic compounds have different properties. Okay, so this image here is the crystal lattice of ionic compounds. That's just a fancy way to say that ionic compounds make 3D crystals. So they are strongly attracted to one another. That's the ions of different charges are strongly attracted to one another, and they kind of gather together to form this crystal lattice. Okay. Each type of ion in the crystal lattice is present in a specific ratio. And that ratio is maintained by their opposite charges or opposing charges. So if you look at the picture here, you'll see that there's like a Cl minus, right? So chlorine has an ionic charge of -1 or 1-, and sodium has an ionic charge of 1+. So those two charges are attracted to one another. And what happens is you end up with like chlorine ions that are surrounded by sodium ions because the charges are opposing. And so they're attracted to each other, just like a magnet, right? So it's like in 3D space, these charges are all attracted to each other, the opposing charges. So it kind of makes this like chlorine, sodium, chlorine, sodium, chlorine, sodium, in the case of NaCl. So NaCl, right, that's the chemical formula for this particular compound. This ionic compound has the chemical formula NaCl. And thinking back to what we did with formulas and Lewis diagrams, neither one of those chemical symbols has a subscript. So we assume that it's 1. So that means for every 1 atom of sodium, there's 1 atom of chlorine. That's what that means. Okay, and those kind of appear together in this crystal lattice. Some properties of ionic compounds. Okay, so they have high melting and boiling points because this crystal lattice we just talked about is really strongly held together. Because it's so strongly held together, the atoms don't move freely, which makes it harder for them to boil, right, to turn into a gas, or to melt, to turn into a liquid, because they're so strongly attracted to one another. Okay, they have a high solubility rating. High solubility. So remember, solubility is a physical property that basically just means it can dissolve easily. And here we're talking specifically about solubility in water. So water, and that's what the picture here shows with the water molecules. So water molecules, the water molecule has 3 atoms, 1 oxygen and 2 hydrogen. And just because the way that the water molecules are formed actually creates what's called a polar molecule. You don't really need to know that for grade 10. That's like a grade 11 and 12 thing. But in order to understand what's happening here, it's good to know that one side of the water molecule is negatively charged and the other side is positively charged. And so what happens is so it's like more positive. There's more electrons on the negative side than there is on the positive side. And so it's not quite the same in terms of attraction as like the ions, but what it does is because of the polarity of the water molecule, it'll actually like attach itself to one of the ions and pull it apart. And so that's why something like salt, NaCl, is so soluble in water. It's because you have these chlorine ions that are negatively charged, and they're attracted to the positive side of the water molecule here. Right? So you have your chlorine ion that's attracted to the positive side of the water molecule, and the water molecule kind of gets in there and just pulls it off of the crystal lattice. And you have the same thing. So this is the negative side of the water molecule, and the positive ion, they get attracted to one another, and it kind of pulls it off. So that's what makes it highly soluble. Okay, so all of that to say, it's going to dissolve in water. Okay? Next thing to know is that it has a high conductivity, particularly when it's dissolved. Okay, this should be an aqueous solution. Oh, that's a hard word to spell in English. I think it's like that. Okay, because ions allowed the rapid movement of electrons in solution. So again, aqueous just means dissolved in water. Okay, you'll see this. So aqueous solution means I've taken this salt, I've put it in water, and now I can pass electricity through it. Okay? Ionic notation. We just talked about that. So again, right, you have your symbol of your element. You have your superscript or exponent, which indicates positive or negative charge at the top right. If there's no numerical value present, that means that it's equal to 1. If there is a number, it always comes before the plus or minus. We just did that, so. All right, how do you name these things? How to name binary ionic compounds. So these are just your run-of-the-mill. I've got a metal and a non-metal. So I have 2 different elements present. Okay, not necessarily 2 atoms. It can be more than 2 atoms, but it's 2 elements, a metal and a non-metal. How do I name it? What you do is you write the name of the metal or the cation first, and it remains the same. Okay, so sodium becomes sodium. That's easy. Then you indicate the name of the non-metal or the anion. You add the ending "ide." Okay, so you might need to take off a little bit of an ending. So for example, like with chlorine, you take off the "ine" and you add an "ide." Okay, so it becomes chloride. So chlorine is chloride. That's it. So if you have NaCl, it becomes sodium chloride. That's how you name it. Okay? This is just a reminder of how you actually write the chemical formula of binary ionic compounds. They're here. So we just did this, right? So you can figure it out using your Lewis diagrams, right? So you're going to draw a Lewis diagram of each element. You move the electrons around, right? So depending on if it's going to lose or gain. And then you repeat as many steps as you need in order to get it so that all of the atoms are happy, right? So that could mean, like in the case of sodium chloride, it's easy because there's only one of each, right? You take this guy, you move it over, you end up with NaCl. But with other compounds, it can be a little bit more complicated, right? So you might have, like, let's say, I don't know, magnesium and phosphorus. So this guy has 5 and 2. So you have to kind of like keep doing this until everybody's happy. So now the magnesium is happy, but the phosphorus is not. All right. Okay. Now that phosphorus is happy, but this magnesium is not. And I keep going. Oh no, I need another one. Okay. So what you end up with is Mg3P2, because that's how many you had to draw. But as you can see, it works. It's maybe a little bit long. You don't necessarily want to do that. Another method that we haven't talked about is balancing charges. So a compound is going to always have a neutral charge. So you have charged ions within the compound, but the compound itself is going to be neutral. So you have to figure out like how many of each will give you the same number of charges. So if we take Ca2 and N3-, right? So calcium has an ionic charge of 2+, nitrogen has an ionic charge of 3-. So we have to figure out, okay, 2 and 3, like how do they go together so that we'll end up with the same number of charges, negative and positive, right? So if you're more maybe math oriented or math mind, you could see that probably the easiest thing right away is to multiply them together. So I need 3, 2+, that'll give me 6. And I need 2, 3-, that'll give me -6, which gives me +6 - 6, that's 0. Okay, that's what's happening here. So I see I have 3 of these guys times 2+ gives me 6+. 2 of these guys times 3- gives me 6-. 6+ +6 - 6 gives me 0. Okay. Or you can use the crisscross method, which we already talked about. So you write them both in their ionic notation. So Ca2+, N3-, you bring them down, and you end up with Ca3N2. And that's your chemical formula. And the name of this compound, okay, is going to be calcium nitride. Okay, so you should be able to go from a formula to a name and from a name to a formula. Okay, and there's homework to help you practice with that. Okay, what is meant by the term binary compound, right? So that's easy. It's just 2 elements. Okay, so before we get going with the names, Remember, we've got a couple of exceptions to think about. So typically we take off the INE ending, add the "ide" ending. But for oxygen, oxygen becomes oxide, like this. Hydrogen becomes hydride, like that. Okay. Phosphorus, well, phosphorus is the same, but sulfur takes a pH instead of an F. Okay, sulfide with a pH.
Wait, phosphorus is the same?
Well, it doesn't say the same. It just doesn't. For a second, I was thinking that phosphorus has an F, but it doesn't. So it's a pH, so it stays a pH. Okay. All right. Calcium oxide. Magnesium bromide. Okay. Pretty straightforward. Let's go down to, we'll do aluminum nitride. Let's go down to rubidium. Okay, so Rb2S is rubidium sulfide. G is calcium iodide. Oops, iodide. Okay, and then the last one we'll do is S. Okay, this one's a little bit weird. It's sodium selenide. Okay, and that's selenium. Okay, so we'll do one of three. Draw the ionic bond formation. That would be using Lewis diagrams. Determine the chemical formula of the compound. Name the compound. Okay, so let's do, I don't know, lithium and nitrogen. That's C. So we're going to start by drawing one of each. Oops. Indicating the transfer of electrons that occurs. So now this lithium is happy, but the nitrogen is not. So we keep going, adding more lithium so that nitrogen can be happy. So what we end up with is Li3N. Again, if you want to do that in a way that's a little bit faster, you would draw your ionic notation for each one and then do your crisscross method. So you end up with this. Okay, that's the chemical formula. Now we're going to name it lithium nitride. Done.